Hi. So for question 3, we've been asked to differentiate two expressions with respect to x. Okay. So if we have a look at question 3ai, the expression is x squared multiplied by e to the power of 3x plus 2. Okay. So we've been asked to find d by dx of this expression, x squared e to the power of 3x plus 2. Okay, so you should be familiar with this notation. If you're not, I've got a little note here. Q layer 1. D by dx simply means to differentiate with respect to x. RWT, you should see in textbooks, it means with respect to x. Okay, so I suggest you familiarize yourself with this notation because they can ask you questions like this. They won't say the word differentiate, they will just simply give you this and expect you to know that you are differentiating this function with respect to x. Okay, so let's begin to differentiate. There's two expressions, there's two terms multiplied together, okay, and it cannot be simplified. So for this derivative, we will be using the product rule. And I have it here, Q layer 2. If a function comes in the form uv, then to find dy by dx, we do u times by dv by dx plus du by dx times by v. Okay, so let's have a look at how this rule actually works. Okay, I'm going to show you an interesting way that you can remember this rule. Okay, so the u, if you notice, has been left. Nothing has been done to the u here. Okay, so we leave the u. I'm going to write an L there for leave. The v has been differentiated with respect to x to get dv by dx. Okay, the v has been differentiated, so I'm going to write a d here. Then we plus the differential of u. U has been differentiated with respect to x in order to obtain du by dx. So I'm going to write a d here. And then v has just been left by itself. So I'm going to write L. LD plus DL, or Lidl. Okay, so it's just a nice way to remember how to do the product rule. And remember, in the exam, you don't get marks for writing the formula, you get marks for using the formula correctly. Okay? So, we're going to apply the product rule, and we're going to use Lidl to help us remember what to do. Okay? So we leave the first term as it is, so that remains as x squared. Then we differentiate the second term. Now to differentiate e to the power of 3x plus 2, this is a function of a function, so we're going to have to apply the chain rule here. So off to the side, we can simply say y equals e to the power of t, where t equals 3x plus 2. Okay? So we're going to find dy by dt. E to the power of t simply differentiates to e to the power of t. Then we're going to find dt by dx. 3 to the power of 3x plus 2 simply differentiates to 3. Now to find dy by dx, we simply multiply dy by dt by dx, and it's as if the dt's cancel out. So we're left with 3e to the power of t, which is equal to 3e to the power of 3x plus 2, because we know that t equals 3x plus 2. Okay? So when we differentiate our second term in the product rule, we get 3e to the power of 3x plus 2. Okay? Now for the next part, we differentiate the first term. So we differentiate x squared. X squared simply differentiates to 2x. Then we leave the second term. Okay? We leave it as it is, so it remains as 3e to the power of 3x plus 2. Okay? So now all we have to do is expand the brackets. Okay? So x squared times by 3e to the power of 3x plus 2. Well, that's just 3x squared e to the power of 3x plus 2 plus 2x times by e to the power of 3x plus 2. Well, that's just 2x e to the power of 3x plus 2. Okay, so now what we can do is simply factorize. It's always a good idea to factorize. Now we can see that both terms have x in common and they both have an e term in common. So I can just take out xe to the power of 3x plus 2 as a common factor. Okay, so for the first time I'm just left with 3x. X times 3x is 3x squared. And then we have the e term there. And for the second term, I'm just left with a 2. Okay, because we've taken out e term and x, and we're just left with a 2. So when we multiply this bracket out, we'll get this result. Okay, so I hope you followed that. That was part I. Now let's move on to part II. Now we've been asked to find d by dx of this expression here. Okay, so there's a few different ways you could do this. You could use a quotient rule because it's presented as a fraction. But what I'm going to do to make things easier, I'm going to say this is identical to 1/3 x to the power of minus 1 cos 2x cubed. Okay, so all I've done here is I've brought up the x. Okay, I've just used my knowledge of indice laws. 1 over x to the power of n is equal to x to the power of minus n. You should be familiar with that. Okay, so now that I have both terms here like this, we can now just apply the product rule. We have one term here and we have another term here, and they're multiplied together, so we can just use a product rule. Okay, so d by dx of cos 2x cubed over 3x just equals the differential of this using the product rule, because these two expressions are identical to one another. Okay, so to help us use the product rule, we use Lidl. So this is our first term, this is our second term. We leave our first term, so that remains as 1/3 x to the power of minus 1. We differentiate our second term. Now, in order to differentiate the second term, again, we're going to have to use the chain rule because it's a function within a function. Okay, there's a 2x cubed inside the cos. Okay, so what we can do, as before, we can just say let y equals cos t, where t equals 2x cubed. Okay, now we can do the same process as we did last time. We can find dy by dt, then multiply it by dt by dx to find dy by dx of this function. Okay, so how do we differentiate cos? Well, you should know that cos simply differentiates to minus sine. And if you struggle to remember this, I'm going to show you a quick way now that can help you. Okay, Q layer 3. So what I like to do is just write sine x, cos x, minus sine x, minus cos x. Or, for short, SC minus S minus C. Okay? And all we do, how this works is simply, when you move down the list, you're differentiating. And when you move up the list, you're integrating. Okay? Sine x differentiates to cos x, which differentiates to minus sine x, which differentiates to minus cos x, which differentiates to sine x. It goes back to the top once you get to the bottom. And the same applies for integration, except we're just moving upwards. Okay, so it's a nice way to remember derivatives and integrals of sine and cos. Okay, nice little quick way to remember it. So to find the derivative of cos, we simply go to cos and we move down one, minus sine. and the variable here is t. So it's minus sine t. Okay. Now, we're finding dt by dx. Now, a lot of people ask me, how do I know it's dt by dx? Because they struggle. Most functions are y equals something x. Yeah, most functions are given y in terms of x. Okay. What I like to say is that we're finding d this by d this. D of whatever's on the left-hand side over d of whatever's on the right-hand side. Okay, so this is dt by dx. If it was given the other way around, it would be dx by dt. Okay, so just d this by d this in layman terms. Okay, so we multiply by the power and minus 1 by the power. So this differentiates to 6x squared, and then to find dy by dx, we simply multiply these two together. Okay, so we're left with minus 6x squared sine t, and we know that t is 2x cubed. Okay, so coming back here, we know when we differentiate this, we get minus 6x squared sine 2x cubed. Okay, then we simply plus the derivative of the first term. So a third x to the power of minus 1 simply differentiates to minus a third timesing by the power x to the power of minus 2, minusing 1 by the power. Okay, then we just leave the second term. So we times it by cos 2x cubed. Okay. Now what we can do is just expand the brackets. Minus a third times by minus 6, sorry, is minus 2. X to the power of minus 1 times by x squared is x. And we have sine 2x cubed minus a third x to the power of minus 2 cos 2x cubed. Okay, and that's our final answer. So I hope you followed, and thank you very much. I'll see you in the next video.